Okay, so in our last few videos, we've gone over single phase heat strips. In this video, we're going to go over 3-phase heat strips. All we've done is we've added one additional row, okay? And we had to add in one additional leg of power. We call that L3. Typically, you see this in commercial units. I've changed out my blower from the previous videos to a 3-phase belt-driven motor. So it's not a direct drive. There are direct drive motors that we can use in the same application, but I chose something that you would probably most likely see. I want to try to gain your confidence and familiarity on what we're doing here, so when you're out there in the field, you can utilize it more to your advantage. Two different contactors are shown up here on the board. We have a 3-pole contactor, so we're breaking all 3 legs, and I have a 2-pole contactor where I'm breaking only 2 legs. So you'll see a lot of 2-pole contactors. You'll see a lot of 3-pole contactors for that too on 3-phase, but you'll see a lot of 2-pole contactors. It is a little bit cheaper to put a 2-pole contactor in. Even if you had to replace a 3-pole with a 2-pole, you can do so because even with heat strips, I can put a 2-pole contactor in there. It's simple. Whatever leg of power that I'm not breaking, it can be 1, 2, or 3. Doesn't matter. All that matters is, and hopefully this video can give you some confidence with 3-phase, is I need 3 phases to run. Now you can also single phase, so you have to be careful when you're dealing with that on motors. You know, you want to make sure that you have all your legs of power there. So I'm not saying that, you know, if I don't have my 3rd leg, I can be okay. What I'm saying is I can put a 3rd leg there and only 1 leg here. I can put a 3rd leg of power here and only 1 leg, as long as I'm breaking the other 2. For example, if I have L1 not broken and down here on my motor L1 not broken, it's not going to do anything as long as I'm breaking the other 2 legs of power. And so if you get confused on why a 2-pole, why a 3-pole when I see 3-phase, it's simply because, you know, you only have to break 2 of those legs, and it is cheaper to break 2 legs than it is to break all 3 legs. So I have them both here, so I'm going to try to help you out on both of those. Real quick, just to wire this up, I like to wire these first without a relay so you can better understand the anatomy. So I'm going to go through this, and I'm going to say 3 will be on the top leg. L1 will be on the bottom leg, and I'm going to have to switch my colors out to get to L2 will be on the middle leg, or when I say leg, I'm sorry. If I misspeak, it is what it is. You know, we're in this together. I've got 3 lugs here. These lugs are what I'm tying my line voltage into. And so as you can see here, I've completed that part of it. Now I have to wire the heat strips. So we have our plate, we have our fusible links, we have our limit switches. If you've seen in the other videos, you know, we've gone over what these other parts are. The circles that aren't colored, those are your ceramic pieces. The circles that are colored, that's just trying to represent different legs. I'm going to color this in the best of my ability to help you out. So don't worry about these colors right now. So if I wanted to just look at this very simply, I can take any combination of the 2, as long as it's balanced, and make this work out. So let's just say L1 and L3, all right? So I can say I'm going to come up here and land on this first one, L3. I'm going to come over on this last one, and I'm going to run up into my limit switch, out of my limit switch, over to my heating element, L1. So I've got L1 and L3. So let's go ahead and write that down. L1 and L3. All right, L1 plus L3 equals 2 legs of power. That strip right there will run. And it's obviously going to run continuous because I'm not breaking that leg. We're not trying to break it just yet. Just trying to show you how three-phase works on a heat strip. Now, I got to have another combination. So let's go ahead and use L1 again. And let's go ahead and add in L2. Okay, so we're going to take L2 and I'm going to run it up to one side of my heat strip. I'm going to take L1 and I'm going to run it over into my limit switch, out of my limit switch, into the other side of the heating element. And now I have L1 plus L2. So, you know, so far we're making progress. Let's look at another combination. What about L2 plus, oops, I'm sorry, I'm trying to, there we go, L3. L2 plus L3. So L2, we would come in and we would land and we would come over with L3 and we're going to land it. Obviously we're going into the limit switch, out of the limit switch, and over. And that's pretty much it. If you look, I'm using L2 twice. If you look, I'm using L3 twice. And if you look over here, I'm using L1 twice. Look, I'm using here and here. I'm using this leg, L2, here and here. And I'm using this leg, L1, here and here. And that's it. So that is literally all that's being done. Is we're now saying that, you know, I can pull ampacity evenly on all 3 legs. That is why we were doing that. So I have now gained a third element. I have shared that load between all 3 legs because I took a combination of L1 plus L3, L1 plus L2, L2 plus L3. All right. It's just as long as you're doing that, I'm going to have the same amp draw on all 3 of these legs. Now, if we were to look at voltage on our meter and we were to try to diagnose, you know, we're going to have to cover that because we did it in our other videos. We actually went through that very, very, very in depth. We didn't have a third leg of power, so we're going to do that now with the third leg of power. First, I want to go ahead and clean this up, and I want to redo it utilizing a relay. All right, so we're going to take and clean this up. It's real easy. Do it all over again. There we go. All right, so we need to come in and break these legs of power. So L1 needs to come in and land on the, matter of fact, L1 needs to come in and land on one end of my contactor. L3 needs to come in and land on one end of my contactor. L2 needs to come in and land on one end of my contactor. Now you know why I didn't do it this way first, because now it's going to start getting a little bit more confusing because we have more going on the board. Okay, and now at this point, it's the same thing as I had up here. I'm back to my 3 lugs. I have to have combination. I've got to have, let's just write it out. I've got to have L1 plus L2. Matter of fact, try to make this a little bit easier. I'm going to go in the right order. Come on. Here we go. Put that back. I did not mean to delete that. Sorry. All right. We're going to say, I'm going to do it in order on my contactor. I've got L3. Okay. That needs to be added in with L2. Okay. I've got L3 again. That needs to be added into L1. I've got L2. That needs to be added over to L1. And then that completes everything. So I've got 2 legs here, I've got 2 legs here, and I've got 2 legs here. So there's my combination. All right, so getting to it, all we have to do is literally just come up and we can say, I want to do L1 coming out, and I'm going to tie in here to my bottom and my middle strips. Doesn't matter which combination you pick, as long as I just land on 2 sides. All right, so that represents my L1 and my L2. So now, very simply, I'm going to take L2, and I'm going to have to come in, out, and back over. That completes that. I'm going to do it with L1. I'm going to come out of my contactor. I'm going to come up into my limit switch, out of my limit switch. That completes my L3 and L1. And then now I got to do L2 and L1. So I'm already have black pulled up, so I'm going to go ahead and come up here and say into the limit switch, out of the limit switch, over to the right side of my heating element, and then I'll switch back to L2, come off the top side of the contactor, and bam. And now that's complete. L2 and L1 are complete. So that's pretty much it. I mean, it's pretty simple. It's complicated only because in our brains we haven't simply understood it. Past that, it's a simple thing once you do understand it. So rewind this video as many times as you possibly need to and watch it. I'm trying to go through these a little bit quicker each time, just because I value your time, especially if you happen to be in the field and you're trying to diagnose and look at this video. So, all right, so we don't have our blower running yet. I'm going to go ahead and just let you know that we have the same terminals that we've always had. We have common. All right, you guys are familiar with this. Run. And flip this over. Start. Let's look at some similarities here. L1, L2, L3. That's simple. Now, all I have to do is break 2 of these legs. If I only break 1 leg, now I have 2 legs of power. Well, that's called single phase. So we say that's single phasing. That motor single phase. It will burn up. That's like your condenser fan motors that are single phase, or blower motors that are single phase that lose the capacitor. When you lose a capacitor, you lost a whole leg of power. It's going to do the same thing. This motor is just going to overheat. There are no capacitors here because we're providing the 3rd leg of power. One of my videos I said 3-phase. Well, technically yes, and this is exactly what I mean by that. All motors theoretically have that third leg. You're given that third leg with a capacitor here. You know, the power company provided it. So we have our 3 legs of power here, and we're only going to break 2. And so I don't want to make this easy and give you a 3-pole contactor. There's no fun in that. So here's a 2-pole contactor. I'm going to go ahead and say we're going to break our run and our start. What color am I using here? Or say, you know what? I can simply come off the bottom side of this contactor in this picture because it's the same thing. So I'm going to come over here and go, here we go. And I'm going to come out of there and come over to my start winding of my blower motor. And then I'm going to come over, oh, red's already prepared for me, out of the bottom side of my contactor for the heater. I'm going to come over here to the bottom side of my contactor for my blower motor, and then out of the top side of my contactor, I'm going to come up to my run side. So now I'm breaking those 2 legs. Motor cannot run. And I'm not going to break my common leg because I don't have to. And I can't with a 2-pole contactor anyways. So we're going to come out. Again, I can just come off of the bottom of this contactor and land it right there for the purpose of this picture. And so now my motor is going to toggle on and off based on the call for my contactor to pull in, and my heat strips are going to toggle on and off based on the call for the heat strip. So let's look at that for a second. We have all of our colors to make it easy for you that are located on the thermostat. Whether it's 3-phase, single phase, pretty much all going to be the same. You know, it's going to take a G call with common to get that blower to come on. Boom, right? And it's going to take a W2 call. Now, granted, this contactor here, I'm going to hold one up so you can see what they look like. Some of them get really big. As you can see, your coil voltage is on the bottom side of it, but this would be very confusing if I sat here and I ran W2 down to the bottom, and the last thing I want is for you not to understand and go and then put high voltage on W2. So we're going to pretend that our 3-pole contactor, okay, has the terminals on the side of the contactor, right? Just so, because it is better for you to sit here and go, there's nothing there, Tom. You know, I don't have anything here on the side. Okay, well, you'll figure it out. Versus you accidentally having one that's on the side, and then I drew it to the bottom. You're going, oh, well, Tom says hook it to terminal 1 or 2 on the diagram, and you know, that wasn't really good because now we sent high voltage all the way back to the transformer on the low voltage side. Gonna be a long day for you, and you probably won't be allowed to leave while your buddy comes and helps you out. He's gonna probably, you know, remind you about it every couple of minutes. All right, so we need to put a common on it. We're gonna pretend again it's on the side of the contactor because this looks very messy. All right, and that's gonna come back over to common. You can see when I do these videos, I try my best to try to not just really dumb it down, but be very careful because as you can see, this is very confusing already. If we started off this way, how am I going to teach? How am I going to explain this simply? It's just not, it's not going to go over very well. Now I will say this, if I wanted to read voltage on this heat strip, if my contactor is not energized, if it's not pulled in, I'm not going to have power anywhere because I'm breaking all 3 legs, okay? So I'll have power up here between L1 and L2, between L1 and L3, between L3 and L2, but I'm not going to have power anywhere on these elements on this 3-pole contactor because I'm breaking all 3 legs. The Motor, however, is going to be different. Because if I look at that motor, okay, if I look at the windings on that motor, we have a common, we have a run, and we have a start, right? And my path of electricity, all right, has put common with power, which is going to energize run and energize start. It's not enough to get this motor to turn, have polarity, and run, because it needs 3 legs. But path of electricity has put power on run and start, and I'm reading common there. And so what that means is if I were to take my meter and use, let's say, the cabinet, the ground lug coming in, and I were to say, hey, do I have power on any of these, then I'm going to obviously have, 115, 110 on every one of these, because I'm backfeeding power between run and start from common. So once the contactor is pulled in and energized, then L3, L2, and L1 L2 and L3 are now going to be energizing start and run, and the motor will run. So with a 2-pole contactor, all right, I'm breaking 2 legs. That means 1 leg is present at all times. I will backfeed voltage, and I will read power everywhere. That's why you want to be able to read across your switches. In this situation, if I read across the switch, I'm going to read common on both of these, because common going through the motor came back here and came back here, which means it was here and means it was here. So all 3 of these are now reading common. So this contactor, if I went between here and here, I'm going to read 208. Between here and here, 208. Here and here, 208. It's the same. If I went between common and ground, I'm going to read 115. If I went between L3 and L2, 208. So it could be a little confusing when you're using 2-pole contactors. Right, so we went over the 3-phase motor. We went over the heat strips that were wired with a 3-pole contactor. To switch it up a little bit, I'm actually going to wire my motor up with 3-phase, breaking all 3 legs, and I'm going to wire my heat strip up 3-phase, breaking 2 out of the 3 of those legs, and show you how that's going to look when there's voltage. Last time there was no voltage unless the contactor was pulled in, and when it was, I had the combination of L3 and L2, L3 and L1, L1 and L2, and L1 and L3. So I'm going to quickly go ahead and do the motor last, and if I do it first, I think we're going to put too many lines on here that's going to confuse everybody. So we're going to first break the heat strips, and then we're going to quickly wire the motor up. Wiring the motor up is going to be very, very quick. All right, so we're going to go ahead and take L3, and we're going to go ahead and just land it on 2 of these. All right, so we have L3 and L3, all right? Now, we have to add in L1, and then land something else on L1. All right, so we're going to go ahead and say that L1 is going to land on one side of my contactor. I'm going to make sure that this wire is big enough to handle the load of 2 strips, 2 sections. I'm going to come off of that same top side, and I'm going to come up and go into one side of my limit switch, out of my limit switch, over to the other side of my element. And now I have L3 and L1. I'm going to go ahead and check that off. And then my other L1, we'll just pick it. We'll say we're going to come up just right here, since it's close enough. All right. So now we're going to go ahead and add in the other leg of power, L3 plus L2, and then L1 plus L2. So L3, okay, plus L2, simple. I'm going to take L2, I'm going to run a big enough wire to the bottom side of my contactor, all right, that can handle the load on both of these strips, all right, and then I'm going to come off the top side of that, and I'm going to pigtail in parallel. I'm going to come up, and I'm going to come in one side of my limit switch, out of my limit switch, over to my heating element. That's L3 and L2, check. And then L1 and L2, L1's already provided up here. We just need to come off the contactor and pigtail and go into our limit switch with L2, out of our limit switch over to our heating element, and there we go. And so contactor pulls in, I have the other two legs present. When the contactor's not pulled in, I have one leg present. So unlike the way we wired it in the beginning of the video with the 3-pole contactor where there's no power present because I'm breaking all 3 legs, here there is power present. I'm going to show you where that is. If this contactor is not pulled in, then I will read power between ground and every single one of these terminals. Every single one of them will have power because L3 is present. So let's go ahead and follow that path of electricity. L3, 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 because L3, L3, L3. Watch this. Back to L3, back to L3, L3, which means we're coming all the way back to here on L3, 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 back to here, L3, up to here, L3, 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 back to here, L3. L3 is everywhere. So, because L3 is everywhere, that's not enough power for these heating elements to run. I need L2 present and L1 present for this thing to operate. So it's 3 different sections of strips. All right, L3 and L1. Okay, there's my 208, 230. I have L3 and L2. There's my 208, 230. And then I have L1 and L2. There's my 208 and 230. And so you have to ask yourself, well, he's breaking L1 and L2. So how did he have power up here between L1 and L2? It's simple. Again, I backfed voltage, L3, L3. Now I have L3. And because I have L3 here, I have it up here. And because I have it here, by the time I run through my entire heating element, it's also present here. Because it's present here, my limit switch is closed, it's here. And as I said, now it's back over here. And so you gotta understand your path of electricity. And again, you know, we have lots of safeties on this. This isn't the video where we're really trying to cover safety. We're just trying to cover ways to break 3-phase and have 3-phase present, and extra why it's important to have that 3-phase. All my wires are now smaller. I can get more load. I have a whole leg of power. I can share that responsibility with other legs, and I can get 30% more productivity out of this piece of equipment with that 3rd leg of power. It's really cool. So you shouldn't be scared of it. Definitely respect it though. All right, fusible links. Fusible link, limit switch, limit switch, limit switch. I told you I was going to wire this blower motor. Pretty easy. We're going to go ahead and just break all 3 legs since it's a 3-pole contactor. I'm going to come down and land every one of these. As quickly as possible. And we're going to say, doesn't matter, a combination, common, run, start. Sorry I didn't change the color. You know, we'll just drag these videos on, which isn't necessary. We all should have the point by now. So in this scenario, the blower is not going to run when these heat strips are running. And this blower won't have any power on it present. Like how I did it before, I had power present because of that path of electricity. So all I did was I just swapped the two around to show you, yeah, I can run a 2-pole contactor on 3-phase heater just as much as I can run a 2-pole contactor on a 3-phase motor. All I gotta do is break 2 legs, and there it is. I'm gonna put a couple of safeties on this just to show you that this can be done a little bit differently. So bear with me. We're erasing it. Why? Because simply we can do it again. There's nothing complicated about it. You should simply understand something. If not, then you don't understand it. All right, so we're gonna go ahead and I'll be nice to you and I'll leave this up here because all we're gonna do is write it down again. All right. These limit switches. Let's just say I wanted to run my low voltage through my limit switch, okay, to turn this contactor off in the event that it opened because my motor went bad or belt slipped off, anything like that. Okay, pretty much we're going to have either W2 or common, it doesn't really matter which one, come through, and I can just simply just daisy chain these, and any one of these that open is going to break common, my path back to my transformer, and I can do that on the W2 or the common. If I did it on the W2, very simple, just the other way around. W2 will come up, daisy chain, there you go, and then path back to the transformer. Either way, it doesn't matter if you break it on the hot side or the common side of your low voltage. As long as the contactor drops out, you're good to go. Me, I prefer the W2 side versus the common side. I think it's a little bit less annoying when you're sitting there trying to find your open and closed switches. If you lose common, you know, on the low voltage side, it's almost like a nightmare to find out where that common is. I'm going to really add a lot of time to it. So is it done wrong? No, but is it cool to spend more time than necessary? No, that's not cool at all. So I personally recommend you break the W2 side. I think you'll speed some time up, and everybody wants you to get it up and running, and that's including the customer. Nobody wants you to spend all day and call a cavalry out there to help you out. All right, so I'm not going to wire up the high voltage side. It's just more wires. I'm trying to express low voltage here with the limit switches. And if I were to do high voltage, I'm obviously going to come down and do L1, one gigantic wire, big enough to handle the load of 2 strips. I can come up here and go 1, 2, there you go, simple. And I can come down with L3 on the other side, and I can come up and go 1, and I'll take this one over here, 2, and now I can sit there and go, all right, done, right? And also, let's see, we got L1 and L3, check. We've got So the other two aren't complete yet. And it's kind of cool that I mixed it up a little bit just there. You know, I even had to stop myself for a second. You know, it only takes a second to figure it out. Now, I'm breaking L3 and I'm breaking L1. So I'm not going to break L2 here. So I'm just going to come in and we're going to finish up and say there. So now L1 and L3, or I'm sorry, L1 and L2, check. And I'm going to come off of my L2 and I'm going to come up to my other one. And now I can say L3 and L2, check. Again, just another way of wiring this up on the high voltage side, leaving one leg present, and another way of wiring it up using common and W2 on my limit switches versus using my limit switches to break my high voltage. Now there are some heat strips. I'll hold one up here. Also another way why I like doing it this way, which can look confusing if I keep adding more wires to it. Imagine if I was trying to teach you on a 12 kW 3-phase heater like this. I mean, think about this for a second. The way I did it, I simplified it. I said, hey, look, we got 1 set, 2 set, 3 set. Well, here's what they did. They've got, let's count them out. 1 set, 2 set, okay. Another set, that's 3, 4, 5, 6. So, I mean, I could draw that up there too. I'm just gonna double it up. It's 6 1/2 dozen another. Doesn't matter how big these get, how long they get, how big the coils are. You know, it's the path of electricity is not going to change. The voltage isn't going to change. I can add a lot of safeties. If you look here, they have 1, 2, 3, 4, 5, 6, 7, 8 limit switches. Some of these limit switches, they open at a higher temperature. Some of these limit switches open at a lower temperature. Also, what they did here is they have these limit switches, these 6 limit switches here. These are breaking high voltage, right? They're breaking L1, L2, and L3. And then these bottom limit switches that I have here closer to the palm of my hand, they're breaking low voltage, right? So they're basically saying, hey, we want a little bit more redundancy. If I want to make sure my contactor drops out completely on the low voltage side, I want to make sure that if I have a problem with not enough airflow, then some of these elements can drop out, and obviously they're going to drop out on their own demand based on high temperature. But that's just how they have it. There are no fusible links. As you know in my other videos, these are my fusible links. I've wrote it down on this one before. At the end of the day, they don't have them here. Does it matter? No. But they have a lot of safeties there, which is still good. If you look at the integrity of these strips, these are really good. These are well built. Different types of ceramic pieces in there. They did a good job. These are good. These are actually Carrier's 12 kilowatt heat strips. And then typically when you're dealing with those heat strips, I'm gonna go off screen for a second to show you. You know, they'll actually have their controls, and they'll have their lugs coming in, L1, 2, and 3, and they'll fuse them. As you can see, you're coming in with a large wire, you're breaking off into smaller, and then you're fusing multiple times. So when you're diagnosing these, you have to understand very simply that I can lose any combination and some of my heat strips are still going to be operable. That's the reason why they put all these redundancies in here, because it's not like you lose one little fuse and the whole thing's not working. So those fuses are actually in parallel, which is cool. Remember I said in some other videos that when you're dealing with heat, not necessarily just dealing with somebody's comfort, you're dealing with life safety too. So I want to make sure that, especially if you're like up north and you never know, it could be a blizzard, it could be anything. You know, you got these as backup or primary. You want to make sure that, you know, not knocking them all offline, which is also very important to understand this stuff. So, you know, when you're dealing with somebody's life safety, you're not jeopardizing, you know, their ability to have what's necessary. All right, hope this helped you out. I'm not going to wire up this bottom contactor. I think you get the point. And if this gets you where you need to go, then mission accomplished. Thanks.